So as he mentioned earlier, it's late on Thursday at SIGGRAPH, so thanks for being here. It's great to see you. My name is Johann, one of the Icelandic easy names, actually. I'm the technical art director at Directive Games, and we're very excited to share with you what we've been up to.
Yeah, my name is a bit more difficult. I am Ólafur, the lead technical artist at Directive Games.
Yes, so let's dive in. Today we want to talk about GENESYS and our journey with procedural generation, Houdini, and artificial intelligence. So excited to dive in. But a little bit of backstory. Directive Games, founded in late 2014 in Shanghai, but now with offices in Reykjavik and Los Angeles as well. Funnily enough, covering all the time zones of kind of 9 to 5, so 24/7. And the team has grown to close to 60 people globally, with most of the team in Reykjavik at the moment. We have a few titles out, actually, so including the Machines AR, Ready Player One, Oasis Beta, and Super Kaiju in VR. We have more exciting titles in production, and we'll tell you a bit more about that. So a video just to show a bit of what we've been up to. Yeah. So this is a video showing some of the early projects in the company's history. But we're not only a game studio. We also build our own core technological foundations or tech stack to help us run and build our games better. So Drift being one of our core technologies, handling various things like user authentication, various other backend things, not my specialty, I will admit. But it's been very beneficial to have. And of course, leading into Camo. That is our very own persistent MMO backend. So whatever you want to persist in your world, from an asset to a pixel, whatever that may be, that's Camo. But leading into GENESYS, and that's more where Ólafur and I step in. So that is our procedural generation, texturing, and artificial intelligence pipeline. Definitely excited to tell you more about that. But GENESYS, what is GENESYS and GENESYS 1.0? How did it all start? Well, back in 2018, we worked on the Ready Player One Oasis Beta, which was actually kind of a catalyst for incorporating more Houdini. So we hired a VFX specialist from London to help us build stronger and better core kind of Houdini knowledge and experience, but then also at the same time schooling him in real-time graphics. It was great to have Peter Breki. He joined us then. But then that enabled us to actually get into the next project. Mm-hmm. So yes, that enabled us to work on a project called Enter the Construct.
Yes, Enter the Construct was the first time we actually fully used Houdini to do some really cool procedural stuff. And in Enter the Construct, we needed to generate an infinite world for players to fly around in 3 dimensions, which is quite difficult. But using Houdini's procedural workflow and excellent node-based scripting and Python support, we were able to achieve this. So after all of the HDA and procedural shenanigans, everything gets converted into a point cloud and written out to a JSON file. And Unreal Engine reads out the JSON file and can assemble the level or the entire world at real time.
At runtime, yes.
Yeah.
In real time.
In real time. So to build complex worlds, we first need a simple set of rules. We look at each element in the environment and give it a place and a behavior and layer them on top of one another so they can influence each other. The principle remains the same. Rather, we are making a three-dimensional level or a two-dimensional level, or even a modular object within the game world. We create the grid, define the area where the world or the object is supposed to be built upon. Then we start grabbing points, drawing some splines, and adding interesting shapes on top of those splines. The shapes and the directions of the splines are specific to like what type of game are we making. In this example, it's more of a traditional shooter instead of the three-dimensional spaceship flying around. And after using the shapes to close off the playable area where the player is allowed to explore, we start breaking it down into modular parts. Then we define each part so they can reference one another and give each of them their own set of rules of how to behave in the world. The parts are layered on top of one another with different priorities. For example, a spawn location for the player is more important than a lamppost in the scene. We don't want a lamppost to get in the way of a player being able to spawn. The layout is deterministic, and we can easily generate the same layout again and again. And a side note, it takes less than a second to generate a level layout and write it out to a JSON file.
Yeah, Bit of Flex worked very hard on getting that down as the networks became more and more complicated.
Yeah. So here I have a video of some comparison of us working in Houdini and transferring the data over to Unreal Engine. And in the particular game, Enter the Construct, we needed this weird shape that we can see right there because we wanted the players to be able to fly around in a kind of a maze, getting lost in this huge environment. This is 3 square kilometers?
Yeah, 3 kilometers square,
yeah.
each cube.
There we can see me jumping from Houdini into the engine, and everything is assembled rather quickly. But of course, we're not using Houdini only to close off the playable area and addressing it with static meshes. All of these random bits we can see there are representations of gameplay objects as well. Light components or enemy spawn locations or destructibles or interactables within the game. And we have a ton of parameters to tweak and polish all of this. The parameters are not just the spawn locations. They can range from like the look of the object to even gameplay variables like how much health the object has or what a visual effect the object should be playing.
Yeah, actually everything in the world was controlled through Houdini, so we ended up putting everything in there, so nothing was allowed to be touched or updated unless it was coming from Houdini.
Yeah. Every point in the scene gets a tag, and we use the tag in the game engine to assign what essentially is supposed to spawn there. And here we can see me like testing out, switching from very, very basic blockout geometry to something more interesting. I'm very quickly just grabbing random modular assets that we have in our library and using the same layout, the same seed to see all of the different variety we get. It makes a huge impact, like the same seed looks like a totally different environment.
Yeah, so we built this out in modular sets. So we were going for a specific look, but then of course we ended up mixing it all up.
Yeah, but
here it gets interesting.
Here it gets interesting. So we've just been looking at a single level for where players will meet in their spaceships and explore and fight stuff. But this is the next step. This is just one level of a network of thousands of levels that we can see right there.
30,000, if I recall correctly, over.
Yeah, I think it's like a Rubik's Cube of 31 times 31 or something like that.
31 squared.
And yeah, then we just use similar methods to control every aspect of the game, not just within a single level, but all of the levels. And all the colors we are seeing right there represent some kind of gameplay attribute.
Like difficulty level or mood and all the different things. So you could switch on like different modes to see what the entire thing looked like. So,
make a few of the levels a boss map, or increase the intensity of the levels in the center of the cube, and have a gradient out from the center with all kind of cool attributes. But yeah, we mentioned camo earlier, our MMO persistent layer, and through camo, because everything gets converted into a JSON file and it's just essentially a text file within the engine, we can really easily jump it back into Houdini, and there I changed the lighting into a green light and the fog into a purple fog, and replaced the JSON file. And in runtime, in real time, even with players flying around, I can update and change the environment. So let's jump through a few of these environments in the construct. Well, remember this particular VFX thing was very difficult to find the spawn location for, because it needed to spawn at the top and the bottom, and of course the space could be dynamic and changing. And but yeah, we could see like when we just left it up to Houdini after we stopped tweaking the parameters ourselves, and we just tied the C to it and let Houdini take the wheel. It was really, really fun to jump through the cubes and see all of the different variations and environments we got.
Yeah, fun for QA to go through 31,000 cubes. Okay, so this leads us all into GENESYS 2.0. So envision a future where advanced AI integration gives developers and players alike unrivaled creative power. AI isn't just a tool, it's a creative partner. So, I mean, with that being said, what does it actually mean? So we started our own exploration of artificial intelligence. We had a company-wide hackathon where we explored how we can use AI to empower our people and projects. So a few of these explorations included training ChatGPT to use Houdini, definitely be diving deeper into that. Generative textures for 3D assets, icon for our games, teaching AI to play our games, neural radiance fields to 3D geometry, or video to 3D geometry, AI motion capture, and NPCs, etc. We had a lot of fun with this one, actually. But, you know, how does it benefit us? What's it all about? Civitas is actually our MMO currently in development. So players own unique land, characters, and buildings. And at its core, towns and cities compete in an evolution race where economical and political warfare can lead to absolute war. This is in kind of a Mobius-inspired stylized look, so very different from what we've been doing in the past. But, you know, exciting avenues of exploration in AI for Civitas is, for example, of course, asset generation. That's kind of a straightforward thing. Show a bit more of that. 3D assets, textures, game icon. But how can we allow AI and players to possibly affect the world? We are very excited about that. But we also have another project that's actually currently in beta, so we can go join us and play that. So the Machines Arena, a top-down hero shooter where players battle it out in PvP and PvE matches in a not-so-dystopian future filled with robots, cyborgs, and humans. It's more colorful than your standard sci-fi dystopia. But interesting avenues for the machine's arena is user-generated content. So generating PvE levels, texture packs, custom game modes, viewer, like we could give content creators tools to be affecting the game at runtime, for example, or having your Twitch viewers join in. There's a lot of exciting things with their own generated content. But at the same time, of course, we really want to flesh out the developer tools for our own content generation, just to build our games out. But
so training AI. So far in all of our generators, and in this one, for example, we sought some inspiration from old school shooter games like Quake and games like that. And we used to just manually tweak all of the parameters in Houdini ourselves, finding something cool that works and yada, yada, yada. And then when we actually wanted to scale this up into infinite proportions, we just tied the seed to every parameter and just let the computer generate thousands of variation for us. But what if the AI could be the one setting the parameters for us? So we created a Python script that sets all the parameters for us by reading data from a JSON file. And then we simply ask the AI to create that JSON file for us. For all of our projects, we have been using some version of GENESYS 1.0. In Civitas, for example, we created an infinite deterministic landscape with the same methods and controls as we mentioned here before. And the landscape is exported to a JSON file, but with the addition of generating a ground mesh that molds itself to other objects and their behaviors in the land. In the same fashion as the construct, the world is nested from a single tile or a cluster of tiles to entire land masses. And in every step, we have procedural systems that layer on top one another and affect one another. But what if we could train the AI to generate the landscape for us? Simply prompt it to generate a desert biome or a dark forest. Or even what about our procedural buildings that we want to use in our game? Could we not only make the AI set the parameters in Houdini, but also generate the texture files we need for all of the elements in the buildings? So here is an example of the first success case of testing this theory. So the user simply writes anything he can think of, a simple prompt, and we have already behind the scenes like pre-written a prompt that explains all of the parameters like step by step in Houdini, what they all do. And then the GPT just interprets from whatever the user types, like what sliders, what parameters do I need to pull inside Houdini to achieve this? And this was the eureka moment in my mind when I saw this test. Like, whoa! I just began with basic boxes, and I asked the language, asked ChatGPT, can you make them bigger, or can you make more boxes, or fewer boxes, or whatever? And then we just started to add more and more parameters, more stuff that we could do with the level, and until we got to a point where we could just start using like. Very broad adjectives, not specific tests or prompts, and just see what the AI decides to set the parameters to. And that's very interesting to see what comes out.
Yeah, I mean, you will always get a valid result with a level, but it just depends on the prompt, is how much you actually are affecting it.
Yeah.
But we didn't stop there. Of course, we wanted to affect more than just the assets and the textures. So we are also setting mood and lighting parameters. So we asked GPT as well to interpret into a few different, just kind of very basic moods that affect the overall lighting in the scene, the lights on the walls, and whatever else we want. It's just an index that once selected, it can affect whatever we want within the engine. So we had our just default lighting, but then added sunny. As you can see there, dark, cyberpunk, of course, and Barbie. Why not? At least very pink. But yeah, as we said, we just took this further and continued to develop.
Yeah,
and it started to take shape.
This is a
dystopian future with dark, gritty textures.
Yeah,
I can stop before. Let's see.
This is where we combined not just Houdini, but also Stable Diffusion to generate textures and parameters within the engine itself, the lighting and the mood.
Yes. So again, getting Stable Diffusion to give us exactly what we want can be tricky, of course. But you get some very interesting, fun results a lot of the times. And of course, the layout continued to evolve and getting definitely more complicated and elaborate.
And we hooked this up to a simple shooter template game that was already working for multiplayer. So it was quite fun to shoot each other in in our
Unreal Engine made that easy. And actually using Lumen to light these levels was definitely helpful too. No baking. Yes, but that brings us to the actual GENESYS Generative AI pipeline. So a lot of testing, and we had, it continued to grow, the prompts. So we actually used to send this all to GPT-4 because we're getting better texture results. But what happened there is just the times always got a little bit longer. Just the LLM was taking a while to give its results. Houdini was very, very fast. But it started to take more and more time. I think we were over 2 minutes at some point. We felt that was just too long. So we actually split the prompt to run two parallel. So one through GPT 3.5, which talked to the Houdini server and the world generation and exported the JSON file very fast, actually. So that loaded up the layout, so you could start running around and check the layout before the textures were ready. So then at the same time, GPT-4 was going through the texture prompts. That's running on the H100 box on top of Stable Diffusion, and generated our textures and updated that all in real time. You were just a player in a map running around seeing this all happen. But we don't want to stop there. So we are working on, so we can now save these. You can save this in persistent. We're using Camo to persist all these things, and you have your own library of your prompts, and you can save the ones you like. But we want you to be able to, let's say you like the layout, but you don't like the texture, so you could just update those, or vice versa.
Yeah, so maybe you loved the Barbie theme, but wanted the cyberpunk layout.
Yeah, so a lot of exciting things to work on there, actually.
And then the idea is that you could share it with your friends, and they could load up the same layout just as you left it.
Yeah, and as we mentioned earlier, for, let's say you're a content creator and you have, your Twitch audience, and you want to share it with them, have them jump into your match, etc., etc. So, yeah, some exciting opportunities there for sure. Okay, so what's next? As mentioned, apart from our kind of developer efforts, supercharging smaller teams, we're working on 2 products at the moment. Well, actually 3 if you include Project GENESYS. It's not a very large team in that respect. So we definitely want to supercharge our teams a bit with the power of AI as well. But how can we make this more player and user facing? So we've taken Project GENESYS a bit further, actually, but we are also well into working on integrating this into the Machines Arena, which, as mentioned, is our game already out in beta. So very exciting to add an experimental feature there where we want to continue to explore this. But also we've been in communications with folks at Scenario GG, for example, and HIVE, and just kind of talking to the others in the community. And we feel it's just such an exciting frontier, and it's been great to kind of share our knowledge and experience with them as well.
Mm-hmm. Seeing other people generating way cooler textures than we are currently, wow, yeah, we will take this a lot further.
Yeah, we've been proving a lot of the core kind of foundations and concepts, but getting the results as artists that we like is a different story. So yeah. So as mentioned, Project Genesis, we definitely wanted a project, a playground to further test these ideas. We've shown you some of what we've been doing there. But as Ólafur mentioned as well, we decided an old school shooter was a good way to test out some of these core concepts. So building on top of the mechanics already available in Unreal. And we, as you may have noticed, but we integrated the Ready Player Me avatars into the project as well. So we do want to release Project Genesis out into the wild. Time box, limited access, just to stress test our system. So we're still figuring out how we can do that best. But great folks at Side Effects have actually, we've been talking to them about how could we go about this. And that's very exciting. So we want to show you a video.
Yeah, we prepared a short video, and of course, it's AI narrated.
In the world of gaming, we're all about pushing the limits. Meet Genesys, a testament to that spirit. It is our internal AI-driven procedural generation framework that powers asset creation in all our games, such as Civitas, Ready Player One Oasis Beta, and more. Genesys is evolving from being an internal tool to empowering players. Genesys enables players to create levels and game rules. From an initial idea, the system begins to weave your concept into reality. Every prompt, every edit brings the world closer to your vision. A new level, new gameplay, all created by you that you can instantly share with friends. Envision a system like Genesys, empowering creators to build a whole new range of experiences. Be it a roguelite dungeon crawler, a thrilling retro shooter, or even an MMO, all sculpted by your creativity. Genesys adds a new dimension to our games. Soon, it will be integrated into the machine's arena, offering players the chance to craft their own PvE levels and other content and share them with the community. We have created an experimental sandbox, codenamed Project Genesys, where we explore and evolve the full potential of the system. This will be available on Epic Games Store in the coming weeks. Be a player, be a creator.
All right, so to close this out before we head into the Q&A, as we said, we're excited to share this both in as Project Genesys and in the machines arena. And so this video is already a few weeks old, which is of course an eternity in AI land. And but we're working very hard on getting this all out because we're very excited to see what happens. So yeah, thank you.
Questions? Going once. Thank you very much.
Okay, thank you.